right, so let's talk about how to convert between different bases. So remember, the base tells you which digits you can use. So if you're in base 10, you can use the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And each place holds a power of 10. So your first digit is 10 to the 0 power, or 1. Then moving to the left, your second digit is 10 to the first power, which is tens. And then your third digit to the left is 10 to the second power, which is 100. And we could keep going. So the fourth number to the left will be 10 cubed, which represents thousands. Okay, so each place holds a different value. So now the base tells you what which each place holds. So here, if it's base 10, then all of these are 10 to a power. And it also tells you which digits you can use. So you're allowed to use 0 up to 1 less than the base. Okay? So if you wanted to have, say, 936 in base 10, that 6 is 6 times 10 to the first, or sorry, 10 to the 0. And then the second digit, 3, represents 3 times 10 to the first. And the third digit, 9, represents 9 times 10 to the second. And we do this in our heads so quickly, right? 10 to the first is 1, so this is 6 times 1, which is 6. And then 10 to the first is 10, so this is 3 times 10, which is 30. And then 10 to the second is 100, so 9 times 100 makes 900. And when we add those together, we get 936 base 10. And it's easier to say because we have hundreds, thousands, like we have common words. When we're out of the base 10 system, we just list the digits from left to right. You say, so we wouldn't say hundreds or thousands because it's not in base 10. So let's see about writing 7F5D base 16 in base 10. So before we can put it in base 10, we have to talk about base 16. So base 16 is allowed to use the digits 0 up to 15, but we've got a situation, right? So 0, 1, I'm going to use ... Once we get to 9, the number 10 has 2 digits in it. We just want one single symbol to represent a digit. So we'll do A, and that's going to represent our idea of 10. B to represent our idea of 11. C to represent 12. D to represent 13. E to represent 14, and F to represent 15. We wouldn't keep going because remember, your digits have to stop one short of the base. So we got to 15, which we're looking at the symbol F as a 15. We wouldn't go then to 16 or G because after 15, this wraps around back to 0. Okay, similarly, each place holds a different value. So all the way to the right is 16 to the 0. And then one digit left of that is 16 to the first. One digit left of that is 16 squared, and 1 digit left of that is 16 cubed. So we're going to use what we know about math to do this. So here, I'm just going to fill in this number here. So 7, and then F, and then 5, and then D. So I'm trying to get some different colors so you can watch. So D represented 13. So in this spot, this represents 13 times 16 to the 0, which is 13 times 1. Remember, anything to the 0 is 1. So that represents in base 10, the actual value 13. Okay, so now let's do the digit to the left. So we're going to bump up the power. So this would be 5 times 16 to the 1. Well, anything to the 1 is itself. So this is 5 times 16, which makes 80. 80 in our regular base 10. Okay, so let's go 1 digit to the left. So F represented 15. So I have 15 times 16 squared. But 16 squared is 256. So I need to do 15 times 256, which I'm just going to do in my calculator. That gives, oh gosh, 15 times 256 makes 3,840. And then last, we're going to do 7 times 16 cubed. So 16 cubed is 4,096. So I'm going to do 7 times 4,096, which is 28,672. Now remember, I'm starting in base 16, but I'm changing to base 10. So my regular base 10 counting comes out by saying thousands, hundreds, etc. So now, if we want to find out this number in base 10, we're going to have to do 28,672 plus 3,840 plus 80 plus 13. So when I add that in my calculator, I get 32,605. So this is the base 10 version of that value, and this is the base 16 version, 7F5D base 16. So I know this is kind of silly, but if you were at a store, you're buying a car or something, then if they told you it was $32,605 in base 10, that would be the same value as if they said, well, it's 7F5D in base 16. Okay, now let's go the other way. So now we want to start at base 10 and go to base 2. So now we know about base 10. Let's talk about base 2. So base 2, that's only the numbers 0 and 1. And the place values are based on 2 to a power. So the rightmost is 2 to the 0. And then to the left of that is 2 to the first, 2 squared, 2 cubed. So that's a squared. This is 2 cubed, etc. Okay? So now let's look at the number 84. 5. So you have to kind of be a little bit familiar with the powers of 2, the powers of the base you're going to. So 2 to the 0 is 1. 2 to the first is 2. 2 squared is 4. 2 cubed is 8. And since 85 is like way bigger than that, we're going to need a lot more places. So I'm going to give a little bit more here. 2 to the fourth is 16. 2 to the fifth is 32. 2 to the sixth is 64. 2 to the seventh is 128. Now 128 is way bigger than 85, so I'm going to start here, but that's only based on what number you're starting with. So the base 10 value, you want the first power of 2, which is lower than the number you have in base 10. So I wouldn't use 128. I would use 64, because 64 is definitely going to go into 85. So we're starting at 85, and 64 is the first power of 2, which is less than 85. So I'm going to subtract 64 from 85. So I can do that. That makes 21. So I could subtract 64 one time. Now, I've subtracted the 64, 21. Can I subtract 32 from 21? No, it becomes negative. So there are no 32s that I can subtract. Now let's do 16s. So can I subtract a 16? I sure can, because 16 is lower. So there's 5 left. So I could subtract 16 one time. Now let's try to subtract 8. So I cannot subtract 8 from 5. So there's 0 times to subtract that. Could I subtract 4? Well, sure, you can subtract 4 from 5. So I'm going to do that. That makes 1. So I subtracted 4 one time. How many times can I subtract 2 from whatever's left over? Well, I can't. So 0 times that I could subtract 2 from what's left over. And then lastly, how many times can I subtract 1? Well, I could subtract it one time. And now I have nothing left over. So if there were any digits to the right of that, they would all be zeros. So if you want to write a number, a base 10 number, in a different base, you have to figure out the powers of the placeholders, like the actual powers, and then also what they represent, like in base 10. And then you look at the one that's closest, or the highest one that's lower than your base 10 number, and you subtract that. And you might, since this is base 2, you can either subtract it 0 times or 1 times. But let's say you're in base 4. Base 4 is 0 to 3, right? Those are the digits. So you might have to subtract it 2 or 3 times before you get to a number smaller than it. So to write 85 in base 10, I would write, or sorry, in base 2, I would write 1, 0, 1, 0, 1, 0, 1, 1, 0, 1, 0, 1, 0, 1. And that's in base 2. Okay, let's try again. So we have 22 in base 10, and we want to convert it to base 3. So for base 3, the digits that you're allowed to use are 0, 1, and 2. And the place values, starting from the right, are 3 to the 0, which is 3. 3 to the first, oh, look at me, I'm so silly. 3 to the 0, that's 1. 3 to the first is 3. 3 squared is 9. 3 cubed is 27. 3 to the fourth is 81. And we could keep going. But we're not, because we're looking at the number 22. So remember, let's look at these guys here. 1, 3, 9, 27, 81. We want the largest number, which is less than 22. So we're going to start here at 9, right? Because that 27 is too big. So we're going to start with 22, and we're going to subtract 9. So when I subtract 9, I get 13. And 13 is still bigger than 9, so I could subtract 9 again. That makes 4. So I subtracted 9 2 times. Now I'm at 4. So let's go to 4 here. 4. I'm just bringing it up since I'm a little out of room. So now I could subtract 3, right? It's either 3 or 1. Well, 3 is the bigger one that I could subtract. So I'm going to subtract 3, and that leaves 1. So I only got to do that one time. I couldn't subtract 3 again because my numbers would go negative. So now let's look at the digit 1. If I subtract 1 time, I'm left at 0. So how many times could I subtract 1? 1 time. So if I wanted to write 22 in the base 3 system, it would be 2, 1, 1, base 3. And again, don't read that as 211 because the word hundred is a word that describes a base 10 value, not a base 3 value. Okay, let's try base 5. So I have the number in base 10, 1,548, and I want to change it to the base 5 system, 1548. I might just write it over here since my stuff is all so squished together. Okay, so we want to convert this to base 5. So let's think about base 5. So base 5 is the digits 0, 1, 2, 3, 4. And the place values from the right to the left, so 5 to the 0, which is 5. I did it again. 5 to the 0, which is 1. Anything to the 0 is 1. And then 5 to the first is 5. 5 squared is 25. 5 cubed is 125. 5 to the fourth is 625. And you have to recognize that I need to keep going because my number is 1548. So let's find the next one. 625. So 5 to the fifth is 3,125. That's 5 to the fifth. That's too big, right? Because our base 10 number is just 1548. So we're going to start with 1548, and we're first going to subtract 625. And we're going to do that as many times as we need to, up to 4, to get a number less than 625. So minus 625 makes 3, 2, and then 6. 9 makes 923. So I think I could do it again, right? Minus 625. I think that makes 298. I think. Always use your calculator. Always double check. So 923 minus 625, 298. Hey, I did it. Okay. So how many times did I subtract 625? 2 times. And then I couldn't do it anymore. So I'm going to move to the right and I'm going to look at 125. So 298 is bigger than 125. So I'm going to subtract 125. That gives me 173. And that's still bigger than 125. So I'm going to do it again. 125. That gives me 48. So I was able to subtract 125 twice. Okay, how many times can I go for 25? So I can subtract 25. Makes 23. And I can't subtract 25 again because it'll go negative. So I only subtracted 25 once. Let's see, 23, I could subtract 5 from that. So let's see, I do it once, and I get 18. I could do it again, and I get 13, and I could do it again, and I get 8, and I could do it again, whew, and I get 3. So I subtracted 5 1, 2, 3, 4 times. Okay, 4 is allowed. Okay, so now what do I have left here? I've got a 3 left, and you can always subtract at least 1, right? Like either you've already got to 0 and you would put a 0 in the last digit, or you can subtract 1. So starting at 3, I can subtract 1, 2, 3 times to get to 0. So the value 1,548 from base 10 can be written as 22143 in base 5. Okay, let's try one more. Convert from base 10 to base 15. So let's talk about base 15. Remember, 15, we need single digits or single symbols to represent our 2-digit values. Okay, so for base 15, we can go from 0 to 14, but we have a problem, right? 0 to 9 is fine, but 10, 11, 12, 13, and 14 are all 2 symbols to represent one value. So we're just going to start using letters. So we'll use A, B, C, D, and E. Okay, so whenever we get the idea of 10 times, 11 times, 12 times, whatever, it's going to look like a letter, but it's going to represent the idea of a number. So the other thing we need are the powers of 15. So the rightmost digit will be 15 to the 0, which is 1. Actually, let me write it below. And then 15 to the first, which is just 15. And then 15 squared, which is 225. And I'll go ahead and stop there. We could keep going, but the number in question is 166. So 225 is too big. So now we're going to take 166 and we're going to subtract 15, because that was the largest number, which was a power of 15, but was less than the number we're starting at. So we're starting at 166. So we're going to subtract 15, and we're going to do that several times. It looks like at least more than 10. But again, you don't need to know, like, if it's a low number and you know, like, the multiplication table, cool. But you can just do this really systematically. So I'm taking 166 and I'm subtracting 15. That makes 151. I can subtract 15 again. That makes 136. I could subtract 15 again. That makes 121. Again, makes 106. Again, like I said, we're going to do this several times. Makes 91. Again, makes 76. Another subtraction makes 61. I'm going to come up here so my list isn't that long, so I'm at 61. I'm going to subtract 15 again. That makes 46. Again, makes 31. Again, makes 16. Oh, we're almost there. And again, makes 1. How many times did we do that? Let's count it. We subtracted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we subtracted 15 11 times. Oh no, 11 is a 2-digit or a 2-symbol number. So we're going to look back and we're going to say, oh, sorry, that's supposed to be a B. Okay, now, how many times can we subtract 1 from what's left over? Just 1 time to get to 0. So that was just 1 time. So 166 in base 15 is B1, and then I'll write 15.